Hey everyone, my name is Rebecca, or Bex, and I'm currently doing a PhD in Advanced Biomedical Materials with the University of Manchester and the University of Sheffield. So, a short introduction to me and how I came to discover my love for biological sciences. I grew up in West Yorkshire and went to a school in a city called Wakefield. My A-levels were maths, music and physics with an AS in biology. And while I was at school, I was lucky enough to be a singer in several bands. And in the summer of 2013, my friends and I raised money to go and help rebuild a school in Dana Nature Reserve in Jordan. As well as being incredibly fun experiences, I never realized at the time quite how useful these things would be when trying to find opportunities following school. After this, I went to the University of Nottingham to study mechanical engineering, for which I got a 2-2. And straight after this, I went straight into a master's in bioengineering, also at the University of Nottingham, and received a distinction. During this year, I quickly came to realize that I had a particular interest in orthopedics, which is a branch of medicine that's associated with the musculoskeletal system. That's the bones, muscles, ligaments, and tendons, etc. within the body. And growing up, I never realized I had an interest in the human body or human biology, but later I'll come to explain how this changed for me. Following this, I had a year outside of academia in which I did all sorts of things, from work experience within a medical engineering department in a hospital in Huddersfield to nannying a 3-year-old and a 5-year-old, and then working full-time as an operations engineer for a company that makes plastic resin and metal historical miniatures. And all of this led me to where I am now, doing an advanced biomedical materials PhD with the Universities of Manchester and Sheffield, although most of my research is done at Sheffield now. A PhD, for those of you who don't know, is generally the highest level of degree that a student can achieve. It involves a lot of specific and often original research on the student's chosen subject. And to do a PhD, you will need to have an undergraduate degree, and in some cases, maybe a master's degree as well. They often last about 3 to 4 years under full-time study. And at the end of this time, you write a big piece of written work called a thesis, which essentially brings together everything that you've done during this time. Although the idea of such a big piece of work can seem really quite scary, everything that you will do that will lead up to this point will give you the skills that you need to be able to do this. You will be able to do it. So my PhD is titled here, a novel 3D osteochondral scaffold with mechano-identical properties of the native tissue for in situ tissue regeneration. That's a rather big title, and I'm sure it doesn't make much sense to any of you. What this means is that I'm looking at designing something that will mimic the natural tissue on the surface of a joint, and it will be able to regenerate and repair this tissue. So the main use for this is for osteoarthritis. Some of you may know someone who's been inflicted by osteoarthritis, and you may understand the effects that this can have on quality of life because of pain, lack of mobility, or inability to bear weight on these joints. In most cases, there's nothing that can be done except for wait until a condition is bad enough and then replace the whole joint with various implants. More often than not, these implants are made of metal. And there are many problems with this, but ultimately, quality of life does not tend to be restored. But with the application of biomedical materials research, we can design something that can be used to treat the tissue within the joint, regenerate any damaged regions, and prevent the need for a joint replacement surgery altogether. So that's just a little bit about me and my research. Now I'm going to talk a little bit about biological science. So what even is biological science? It's quite a vague term. Biological sciences can cover a wide range of specialist areas that are all concerned with the science behind living things. So most biological science courses, you will also have the opportunity to undertake either some lab work or some field work, or both, if this interests you. And some typical areas include biochemistry, biomedicine, genetics, environmental science, physiology or sports and exercise science, zoology, biomedical engineering. And I'm going to give you a brief introduction to all of these topics and why they can be so interesting. So biochemistry, this is the topic that explores chemical processes that are related to living organisms. So there's a heavy focus on structures, functions, and interactions of biological molecules. An undergraduate degree in biochemistry can provide several opportunities in a range of areas, whether that's in industry, academia, or research. And some examples of the jobs you could move on to from a biochem undergraduate are as an academic researcher or a research scientist, a biomedical scientist or a biotechnologist, a forensic scientist, a physician associate, a pharmacologist, or you could even move away a little bit from biochemistry as the transferable skills that you'll develop. You could get a job in the field of accountancy, environmental engineering, neuroscience, toxicology, and there are several more as well. Biomedicine. This is the branch of medicine concerned with a wide range of technological and scientific approaches that are based on molecular biology and molecular medicine. So medicine itself studies how to treat diseases and what they are. Biomedicine studies the human body and its organic processes in a greater depth so that we can gain deeper knowledge surrounding the biology of human diseases and understand the specific causes of conditions. Biomedicine is so important for breakthroughs in medicine and healthcare, and it's responsible for several fantastic innovations within healthcare so far. A few examples being discoveries in cancer immunotherapy, artificial intelligence that can be used to predict individuals' risks for developing diseases, or development of drugs to treat diseases such as cystic fibrosis or Alzheimer's. An undergraduate degree in biomedicine could lead you into a career like an analytical chemist, a biomedical scientist, a biotechnologist, a clinical scientist in biochemistry or genomics, hematology, which is the study of blood, or immunology, a forensic scientist, a microbiologist, a research scientist, or you could even use this degree to branch further into jobs like a crime scene investigator, a dental therapist, an environmental engineer, a genetic counselor, or a medical sales representative, for example. Genetics is the area of biology that is specifically concerned with the study of genes, genetic variations, and heredity in organisms, meaning how traits are passed on from one generation to another. Geneticists can be involved in some groundbreaking work, such as cancer research, inherited diseases, genetic engineering, or even designing new antibiotics. An undergraduate degree in genetics could secure you a job in academic research, clinical science for either genomics or immunology, a genetic counselor, a pharmacologist, a biotechnologist, an epidemiologist who studies the patterns, causes, and effects of diseases in groups of people, a forensic scientist, a medical sales representative, or a scientific writer, etc. Environmental sciences integrate several scientific areas, such as ecology, biology, physics, chemistry, plant and soil sciences, geology, physical geography and mineralogy, and even oceanography and atmospheric sciences. In order to study the environment as a whole, or environmental systems, and attempt to provide solutions to environmental problems. This is, at the moment, a very important area of study. With a degree in this topic, you could get a job as a horticulturalist, who is someone who uses their scientific knowledge to cultivate, grow, move, and breed plants. This could be to create public outdoor places, such as parks and gardens, or to have a hand in the growing and distributing of crops and plants for food, for example. An environmental consultant, an environmental engineer, a nature conservation officer, a recycling officer, a landscape architect, a town planner, toxicologist, or a water quality scientist, or a water engineer. Physiology, or sports and exercise science, has to do with understanding sports performance and several factors that can affect or impact this. Physiology is specifically the study of the human body, how it functions under normal conditions, and the chemistry and physics behind basic bodily functions. An understanding of physiology and sports science can be used to work towards some of the best physical achievements, helping athletes push their limits. For example, using sports and exercise science, you could improve on every aspect of physical performance to help break that 2-hour marathon record. or assisting physical therapy that can improve recovery times following accidents or surgeries, allowing individuals and athletes to get back to the physical activity in their lives. Analyzing data from football players and their games in order to devise individual plans for the players to help them go and win the World Cup. And jobs that you can go into following this undergraduate degree include exercise physiologist, a fitness center manager, personal trainer, a sports therapist, sports development officer. The degree could even help you find a job as a choreographer, a clinical scientist, a health improvement practitioner, a nutritionist, or a sports and exercise psychologist. So zoology is the branch of biology that is associated with studying animals. For example, this could be their evolution, their classification, structure, or interactions with ecosystems. You can do all sorts of wonderful things with zoology, such as protecting animals from threats, whether they're man-made or natural, researching cures and preventing diseases, fighting extinction, and understanding the psychology and behavior of animals. With a degree in zoology, you could go on to be a zookeeper, a gamekeeper, a zoologist, an academic researcher, an animal nutritionalist, a marine scientist, an animal physiotherapist, or you could even go on to be a vet nurse or surgeon. And finally, the area that I personally understand a little bit better is biomedical engineering, also referred to as bioengineering sometimes. So biomedical engineering brings together design and engineering with human biology and medicine to create equipment and devices to improve human health. For example, this could be software to run medical equipment, prosthetics or implants, or clinical equipment used in hospitals. Biomedical engineering has already demonstrated some really cool and useful innovations, such as combining medicine, biology, and robotics to develop robots that can help perform surgeries, shown in the picture down there. Another exciting innovation that comes from biomedical engineering is the exoskeleton. So some of you might be familiar with the sorts of exoskeletons you can get in games, for example, in Call of Duty. And these gaming exoskeletons have actually helped to inspire the development of medical and military exoskeletons. Once again, combining human biology with engineering through robotics and mechanics, the development of a user interface, necessary software that goes with it, and consideration of the materials to make sure that they're strong enough whilst also maintaining minimum weight. In real life, exoskeletons can successfully give the wearer more power and endurance. So in a medical sense, there are millions of people in the world that are wheelchair users and millions more who have a condition that can make moving around rather difficult. So for such individuals, a medical exoskeleton would be a wonderfully useful piece of tech that could change their life. And military exoskeletons can give you extra super strong strength, prevent you from tiring, and provide high-tech body armor. So from a biomedical engineering degree, there are several job opportunities, the most relevant being found within hospital trusts, medical equipment manufacturers, university research departments, or other research units, for example, industries who are designing new medical implants, rehabilitation or health charities as well. As well as being able to go into a career as a biomedical scientist, you'll develop skills that could enable you to go into jobs such as software engineering, a clinical scientist, a financial engineer, a project manager, or even a medical writer. So what's so great about biological sciences is that in the biological world, the biological world is everywhere. And we still have so much more to understand about the living world and how it works. Throughout your time at university, you could have the chance to conduct your own work or research into something unique and of your own choice, and whilst being able to be supported by the university as well. Biological sciences can offer the flexibility to collaborate with other disciplines and engage science in a whole variety of areas, as we've just seen. A university experience can be a really interesting opportunity, whilst also developing skills that are attractive to other employers, such as time management, communication, teamwork. And as you've seen, you can go into a variety of different careers from biological science degrees. So finally, I'm just going to talk about something that I believe is one of the best things you can do for yourself at the moment. In my opinion, there is nothing as beneficial as throwing yourself into opportunities. You really never know what you could learn, or it could introduce you to something completely new and unexpected that you might never have discovered otherwise. So work experience is one of the most valuable things you could do for yourself. Although there are times when it can be really slow paced, especially if you're too young to take on any real responsibility. And the working world can be really quite scary for the first time. I know I was very nervous, but there are so many benefits if you stick it out. So firstly, you could learn what does and doesn't inspire you. Growing up, I was good at maths and I didn't really think I could do anything else. I believed for years that I would do a maths degree, and I was quite worried about where this would lead me afterwards. So what job was I going to get, and would I enjoy this job? So because of this, I started to do some work experience around the time of my GCSEs and A levels. And I just Googled some jobs to do after maths degrees and looked at the most typical ones. So I did a few in accountancy and KPMG, and then eventually moved on to doing some work experience in companies like Arup and Rolls-Royce. But I was too young to take any real responsibility here. Things felt quite slow. However, in comparison, I found that my engineering placements were far more stimulating than the ones in accountancy, and I felt like my interests lied here. From these experiences, I realized that although I was a big maths person, mechanical engineering was a much better degree fit for me. And since then, I'm so glad that I've realized that this before I even began a degree in maths. A second big benefit to different opportunities and work experience, potentially the biggest advantage, is how this can help you stand out from the herd. I didn't receive the grades that I needed to be able to go and study mechanical engineering at the University of Nottingham, but the fact that I'd done so many work experience placements and a few other jobs demonstrated to the universities that I'm a dedicated hard worker with a go-get attitude. And this has been a real benefit when trying to find other jobs and experiences, etc. To this day, I still believe that my work experience and my attitude of sort of like going and trying all experiences has really helped me get this far without being as academically inclined as my peers. As I mentioned before, I would have never predicted that I would have ended up in a discipline that involved human biology. But while studying my mechanical engineering degree, I had a job along pretty much all the time, normally in pubs and restaurants and entertainment areas. But one day I fancied a change from the retail sector. And although I don't know what inspired me to do so, I decided to go into care work and began working for a company where I cared for individuals in their own home. During this time, I noticed that engineering doesn't just fall within the categories I was familiar with, but it was actually applicable everywhere. The equipment that some people had installed into their homes was incredibly useful and in some cases really fascinating, varying from the typical stair lifts and hoists that many people are familiar with to things like robotic add-ons and extensions to wheelchairs. So throw yourself into new experiences and opportunities, because you really never know what this could do for you in the future or what this could introduce to you, which could then lead you onto something else. So that's everything from me. Thank you so much for taking the time to listen to this talk. I hope there's been something that you found interesting or useful. And finally, good luck with everything that you have to come.